to wash your whites separate from your darks? I know I do, because I wear clothes every day. Although my mom washes my clothes currently, I'll have to learn how to do it one day. I'm also very interested in fashion.
Chemistry is involved in all the making of clothing, from the making of the fabric, to the dyeing of the material, to the proper washing techniques. By that I mean making sure that your favorite white t-shirt doesn't turn an awkward pink color when you wash it with your reds. You probably already know that this will happen when you wash your whites and your reds together in hot water, but why? First, let's talk about the chemistry that goes into dyeing clothing. Some dyes, such as the kind you can buy in the grocery store here in the United States, really just stain clothes so the dye washes out a little every time you wash it. Sydney, what are dyes?
Dyes are substances applied to aqueous-based solutions to a fabric to give it a color. What makes a dye different from a pigment is that pigments are usually insoluble. In India, they have been using methods of dyeing for over 5,000 years. Most of the dyes that they use are known as natural dyes found in the plant kingdom, available from a number of roots from berries, bark, leaves, and wood.
The structure of dyes, you may have noticed sometimes when you wash your clothes, that the color may seem to seep out of them. This is a result of when you dry your clothes. They seem to become faded. Some dyes just stain fabrics and get washed away bit by bit whenever you wash your clothes. Good dyes, on the other hand, chemically attach themselves to the molecules of the fabric that you are dyeing.
Different dye molecules are unique. Each is shaped differently so that it absorbs light in a different way. This results in the color of the dye being different. Often, a third molecule is added to a dye. This acts as a bond between the dye molecule and the molecule of the fabric that the dye is being applied to. A few examples of dyes are acid dyes, which are highly reactive water soluble dyes that are used to color fabrics like wool, silk, and nylon.
Mordant dyes use a substance that fixes the dye, making it resistant against water, light, and perspiration. These dyes are usually used for coloring wool.
Basic dyes are used with acetic acid to dye acrylic fibers.
A molecule is much too tiny to see, but we can use models to show what the dye molecule is shaped like. Each of these octagons represents a different sort of atom. The O's are oxygen, like in the air you breathe, and these Cl's are chlorine, like in bleach. This model shows you what the red molecules in this bottle of red are shaped like.
If you put these two molecules together, the cotton and the dye, nothing will happen, unless you can get some of the atoms on the surface to come unstuck. For example, hot water can cause this. If the H comes off of the cellulose and the Cl comes off of one of the end of the molecules will be able to react with each other and stick together.
The fabric your clothing is made out of is also made of molecules. Cotton, which grows on a cotton plant, is made of long strands of cellulose molecules, all twisted together. When the dyes react with the fabric, they undergo a chemical reaction with the fiber, during which they form a covalent bond to the fiber. The dyes have a reactive molecular group on them that reacts with the hydroxide group of cellulose fibers.
Enzymes work the best in hot water. This tells us that when you wash your red shirt with your white shirt in hot water, the enzymes in the dye allow for the red dye to release color onto your perfectly white tee.
New Game Flings smell so amazing, they're like music to your nose.
Your love keeps lifting me higher and higher.
Lift your love with new Gain Flings. More gain scent than ever, plus OxyBoost cleaning power and Febreze. It's our best gain ever.
Higher and higher. Higher and higher.
New Gain Flings.
One.
To prove our theory, we are going to perform an experiment. To start our experiment, we're going to take our perfectly white tea and accidentally turn it pink.
Now we will put in our red items. We have 1 sock, 1 red tea. Go Knights! We have Sydney's favorite t-shirt, but not the white one. We have some red basketball shorts, some unmentionables, and 1 red shoe.
Don't forget about our fabric softener. It'd be a shame.
Sid, the wash is done.
Oh. Oh, fiddlesticks. There goes my perfectly white tea. So Devon, what does this crazy chemistry gibberish mean to you?
Basically, it means that due to the structure of the dye molecule, it'll release itself off of one piece of fabric to the other, especially in hot water. So don't wash your whites and reds together in hot water.
Wow. Are we done?